My name is Scott Kofod. I'm principal scientist with Cargill Deicing technology. I'm in my 23rd year now with Cargill and working in the deicing industry. And I'm pretty confident in saying that our industry has come a long ways in the last 23 years. We've learned a lot about how to do deicing more effectively and more efficiently. And of course, a lot of this knowledge has come from many decades of field experience. And all the stuff that we've learned or much of the stuff we've learned is summarized in some very useful references that you may be familiar with. So these include things like the FHWA Manual of Practice for an Effective Anti-Icing Program, the SALT Institute's Snow Fighter's Handbook on Safe and Sustainable Snow Fighting, the NCHRP report on Snow and Ice Control Guidelines for Materials and Methods. These are all extremely useful resources to give us guidance on how to apply and use our deicing chemicals. But we also know by experience that deicing is a fairly complex phenomenon, and it's influenced by a wide range of variables in the field. So any guidelines for field application are of course going to be general at best. Furthermore, there have been a number of new products and technologies that have been introduced to our industry in recent years that we are still in the process of understanding and using in the field and trying to get a better feel for how they work under field conditions. So because of this, while these general guidelines that we have are very, very important and useful, and they're absolutely where we should be starting to give us guidance on how to apply our deicing chemicals, I think that there's also value in having a more basic understanding of how the chemicals that we use actually perform. The better we can understand how the chemicals we use perform, the better we're going to be able to tweak and refine those more general guidelines that we have on field experience to the particular situation that we're dealing with. Also, hopefully, the better we understand how chemicals perform, the better we will be able to optimize our chemical formulations and make them work the best for a given condition and perhaps help us develop the next generation of deicing products. So how do we do that? How do we measure the performance of deicers? Well, of course, the ultimate measure of deicer performance is always how does it work in the field. But it turns out that field experience is not the best way to get a detailed understanding of how different products or techniques compare to each other. And that's because field tests are notoriously difficult to do. There's too many variables that can't be controlled. Because of the high amount of variation, we need high test replication. That is, we need to collect a lot of data to make any conclusions. Finally, data acquisition quite properly takes a backseat to safety. If we're trying to measure the performance of a deicer during an actual snowstorm, obviously our first priority is to get that road safe as quickly as possible. And as a result, it often makes collecting careful data more difficult. So while field tests are the ultimate proof of the pudding for the effectiveness of any product or any technique, I would like to suggest to you this morning that laboratory tests are also very important. Laboratory tests, while not as real world, have the advantage that we can control all of those other variables that make field measurement so difficult to help us better understand what's going on and how our deicing chemicals work.